Hello everyone, we Mindsafe innovators are here to present an innovative solution to a critical issue in the mining industry. My name is Abhinav Sharma, the leader of the team, and other members of my team include Arjun Bharadwaj and Aditya Dua. Now, as it is quite evident that mining as an industry is a stressful and often quite a dangerous occupation as it involves both environmental and health risks for the workers in the mines. Thus, our problem domain revolves around the communication and hazard prevention sector of the mining industry. Coal mining is a critical industry which comes with its own risks, which occur primarily due to involvement of slow and inefficient communication technologies with a lack of real time insights on the current situation, which often is a result of manual monitoring systems in place. To solve this problem, we have built a working prototype of a smart helmet capable of monitoring environmental factors such as concentration of methane and carbon monoxide, which are responsible for most of the gas related accidents in the coal mines, alongside each worker's pulse rate, which can be used to monitor their health in the stressful conditions underground. The main problem we have solved is the communication of data in real time, as any Wi Fi or cellular networks can be hard to implement underground. So, we have chosen the LoRaWAN or long range wide area network technology, which is a low power communication method with range covering several kilometers, which will enable real time monitoring of the data from all workers. Talking about the hardware, the helmet utilizes three main sensors for data collection: MQ4 and MQ9 for measuring concentration of methane and carbon monoxide respectively, alongside a MAX30102 pulse rate sensor to monitor workers' health. For LoRa communication, each helmet is equipped with a SX1278 LoRa module, which works on SPI communication in half duplex mode. The integration within the system will be handled by an Arduino Nano 33 IoT board, which has a powerful ARM Cortex SAMD21 based 32-bit processor with IoT capabilities via a uBlox Nina chipset. The system is powered by a 12-volt battery with a LM7805 voltage regulator to provide stable 5-volt supply to the system. And next is the software part, which includes three software technologies being used, with first one being the Arduino IDE, in which the code to run the system via an Arduino board is written, keeping fault tolerances in mind, such as data validation or system responsiveness checks using timers, etc. The next technology is React, which is a front-end JavaScript library used to develop an intuitive, responsive, and appealing web application for this project. And the last one is Google Firebase, specifically the real-time database, which will store each helmet's data and then display it on the website. Now let us discuss the operation of the complete system. For a minimal setup, which includes a slave unit, which is a helmet alongside a master unit, which is the surface Arduino system. The system starts with the helmet, which takes live readings from the onboard sensors and then transmits it to the surface station via LoRaWAN communication, and the station then forwards the data to real-time database via onboard Wi-Fi chipset. Then the web app displays the each worker's data in form of a card interface. This is it for the brief overview of a project, and for in-depth information on the project, the link to our article is also mentioned below. And now let's start with the system demonstration. As you can see, this is a setup which includes the helmet, the surface station, real-time database, and the web application. First is the helmet, which includes a PCB with all the components placed as shown in the image. The system is powered by a 12-volt battery with LM7805 voltage regulator. The connections can be seen on the screen for all the hardware in this unit. Next is the master unit or surface station, which receives data from each helmet and uploads it to the real-time database. The system only has three components. First, an Arduino Nano 33 IoT board for transmitting to Firebase via Wi-Fi. Second is the SX1278 LoRa module for receiving data from the slave units. And the last one is the antenna for extended range of the LoRa module. And the connections can be displayed on the screen as well. And after the data is uploaded, it is updated on this Firebase interface in real time with each user ID as an identifier for each individual helmet sensor data. Historical data is also stored to display a graph of the data for better visualization and analysis. The final interface or the GUI of the system is this web application, which can be visited by following this link. On opening the website, the first page is a login page to provide access of the data to only the authorized personnel. And now I will sign in with my credentials. And after a successful login prompt, the main dashboard will be visible with easy to navigate interface and each helmet's data being displayed as a card. The system is set up in such a way that if a new helmet is deployed and data is transmitted to Firebase, the web page will automatically create cards to display the respective data. And now let us power on the system. For that, I will ensure that the station is receiving power and the web app is also opened. Next step is to connect the battery with the helmet to start the system. The lights on the PCB and the pulse sensor indicate the status of its power, and after some time the data will start uploading, and as it takes around 2 to 3 minutes for pulse data to calibrate, so it may provide lower values for that time period. This concludes my project demonstration for the unit of SIT210, and thank you all for listening.